Okay. So dear student, let's start the discussion for the spot exam number 2, right? So I think you already have go through the paper and give some effort to obtain the answer, right? So let's start the review these questions, right? So let's start from the first one. Uh, in the first question, you are asked to which is measured by electron volt, right? So I think it's a type of a unfamiliar unit for you, right? But even though you have to get um, adopt this kind of units also, right? Okay. So first of all, I want to mention you some important things regarding its energy, right? So guys, there are various type of energy, isn't it? So what are they? Potential energy, kinetic energy, light energy, heat energy, and wind energy, sound energy, nuclear energy. So those are the number of types of energies, right? So when we come to the unit of the energy, so I want to know what is the SI unit of energy. So if you are asked to obtain the SI unit, just recall a relevant equation for energy. So what is the tell me a relevant equation? Let's get potential energy. Now you know that the relevant equation for potential energy, isn't it? So what is the relevant equation for potential energy? It is mgh, isn't it? So if I substitute the relevant units for this equation to obtain the SI unit of potential energy, even though it is a potential, I'm looking for obtain the unit of energy, right? Okay, let's substitute. M mean kg, g mean is acceleration. So it is, let's substitute the unit of acceleration. H mean is the height, so that means the length. So then this is the unit of potential energy. Even though, so this is the unit of SI unit of energy, right? kg in squared is e to the power minus 2, right? Guys, this is the SI unit of energy, right? Okay, even though now we have learned that there's a special name which is used as a unit to measure the energy. So what is it? It is obviously joule, right? So this is the SI unit. This is the SI unit of energy. But normally there are some special units. First one is joule, right? Joule is a unit which is generally used to measure the energy, even though this is the SI unit. But and so so when we come to the electric energy, most of times we use some specific units to measure the electric energy. So that is kilowatt hours, right? So this is the unit which is generally used to measure the electric energy. Even now, electric energy is also under the also type of energy. That's correct. But even though normally we are using this unit to measure the electric energy for the practical purpose. So this unit is the is generally used to measure the electric energy, right? So likewise, when we come to the nuclear energy, nuclear energy, generally we use this kind of unit, that is electron volt. So it is further can be clarified as mega electron volt. So how should we pronounce it? Electron volt. Electron volt, right? So this is pronounced as mega electron volt, right? So I think it's better to have an idea regarding those stuff, especially about the energy. And I want to mention you another important fact, that is uh, energy and work. Energy and work having a same set of energy, right? So normally the unit of the energy as well as the work having a same units, right? So keep in mind those stuff uh, regarding the energy. So let's come to the question. A question asking about the what is the measure, which is measured by electron volt. So that's it. So the answer is, it's already have. What is the answer today? It is energy, right? So I will tell you those stuff to obtain the answer, right? So even though this is a discussion video, I want to highlight to you some important facts uh, regarding the questions, right? So I will tell you some backgrounds, theories, or some important points relevant with these questions, right? Okay, so let's come to the second one. What is the measured by kilowatt hours, right? Kilowatt hours, which is used to calculate the electricity consumption of houses. So it's obviously this unit is used to measure the electric consumption in the house or in the industries, right? So normally, generally we call 1 kilowatt as a one unit. So normally, in the electricity bill, it is mentioned that the unit which have consumed during this particular month, right? So unit is equal to 1 kilowatt hour, right? Okay. Yeah, so the answer should be the fifth one. In the third question, 1 nanometer equals 2, right? So now you are asking about the a conversion, isn't it? Now you are asking about asking the conversion, right? The question is 1 nanometer equal to, and they have given some relevant answers, right? To obtain this answer, you have to consider you have to make a conversion of each unit to the you have to convert nanometer to the given units, right? So let's take the first example. In the first answer, the value is given in millimeters. So let's convert nanometer into millimeters. So we can able to cancel this one. Nano mean 10 to the power minus 9. Milli mean 10 to the power minus 3. So the answer should be 10 to the power minus 6, right? So in order to convert 1 nanometer to millimeter, you have to multiply the given value from 10 into the power of minus 6. So this is the answer. Even though the answer is giving in a fault one. So the first one is not the correct one. So let's move on to the second one. In the second answer, it is given as a centimeter value. So let's convert this nanometer into centimeter. Right. So these are cancelled each other. Nano mean 10 to the power minus 9. Centi mean 10 to the power minus 2. So the answer should be the 10 to the power minus 6. So in order to convert this nanometer into centimeter, you have to multiply the given numerical value from the 10 to the power minus 7. So the second one is also incorrect. So this is the way that we normally use to obtain the answer, right? Even though it is a it's a long it is a questions which is take some uh, sometimes to obtain the answer, right? So if you are lucky enough, you can able to obtain the answer from the first or second answers, right? But even though, right? So keep in mind that the third one is also is given as a centimeter value. So if it is a correct answer, it should be 1 into 10 to the power minus 7. So the third one is also incorrect, right? Okay, fourth one is also incorrect. And fifth one, in the fifth one, you have to convert nanometer into meters. So in order to obtain the meter value, you have to multiply it from 10 into 10 into the power minus 9. So that's mean we can't able to get the correct answer for these questions, right? Because all the given answers are incorrect. So this is the answer for the third question is 4, because all the students obtain a 1 mark for this kind of questions, because there's an issue in the answers, right? So that's why you will be given the mark at the exam, right? Okay. So in the fourth question, which of the following is not a unit of energy? Right. So this is the second time that we are asking. This is the third time which is asking about the energy. Right. So let's come to the theories that we learned. Okay. Now we are asking to obtain the unit of energy. Right. So as I mentioned earlier, there are several types of units to measure the energy. So what is the first one? The SI unit mean kg m into the power 2, s into the power 2, s into the power minus 2. So this is the SI unit. And we can also use kilowatt hours or electron volt or mega electron volt, and we can also use the joules to measure the energy. So these are some of the units which is used to measure the energy. So let's go through the answers. Just keep the first one. The second answer can be accepted, right? It is joule. What is third one? Just forget the first and third. So second answer should be correct, right? Second one is correct. Fourth one is also correct, isn't it? Because it is mentioned the kilowatt hours. And in the fifth answer, what is it in the fifth answer? That is gram centimeter into the power 2 is into the power minus 2. Right. So guys, just try to obtain the relationship between these two. It is similar units, but both these units are is co-equal, isn't it? Because this is this unit is given in another type of set of units, right? So here kilogram is converted into grams, meters convert the meter square converted into centimeter square, and s minus 2 is also given as the same unit. So this answer also can be accepted, because this unit is similar as the SI unit of the energy, right? So the fifth answer can be also accepted, right? So guys, these are something some some freshy things for you, right? So you have to adopt these kind of units also, right? So these are some derived units by using the SI unit of the energy, right? Okay. So let's go through the first and the third one, guys. I mentioned that uh, energy and work is a correlated physical quantities. That means in the future you will able to learn about those stuffs, right? So up to now, just keep in mind that energy and work are correlated physical quantities, right? Uh, so that's mean the unit of work also can be considered as a unit of energy, right? So I think it is some kind of um, some doubtful facts for you, right? Even though, guys, keep in mind that work, the unit of work and the energy. Just keep in mind that work and the energy having a uh, correlated physical quantities, right? So they are same equal quantities, right? So therefore, the unit of the work can be also considered as a unit of the energy, right? So what is the equation for work? Work means force into distance, right? So this is the equation which is relevant with work, right? So let's substitute the unit for this one. So normal generally we measure force in Newton and distance in meters. So Newton meter is the general unit which is used to measure the work, right? So I repeat it. This is not SI unit of work, right? This is the general unit which is used to measure the work, right? So here instead of instead of Newton, sorry, instead of meters, we can able to consider centimeters, right? Right. So this means this unit also can be considered as a unit of energy, right? So the third one is also correct. Then the first one is the answer, right? Keep in mind that what is the unit of is a power. What is the unit of power? Right? What is the unit of power? So further we can able to convert this watt value into kilowatt value. So even though it is also a unit of power, right? So the answer should be the first one, right? So I think in this question you can able to learn some lot of things regarding the unit conversion and the similar units, right? Right. Let's come to the fifth question, right? Which quantity has been given with incorrect unit? Incorrect units, right? Okay. Incorrect units, right? So first of all, I want to mention you a some right. Previously, I mentioned that guys, there are some similar units which can be observed when you learning or when you go through these units, right? So first one, keep in mind that work and energy having a correlated units, right? So the units of the work and the energy can be considered as a can be unit and sorry, energy and a work having the same set of units, right? So likewise, I will tell you some another examples which having a same set of units, right? Keep in mind that work and energy having the same set of units, and the other thing is momentum and impulse. These are two physical quantities. These physical quantities having the same set of units, right? So likewise, that's another example, that is pressure and Young's modulus. Young's modulus. Just remember the name of these physical quantities, right? Especially like Young modulus, right? So these are very freshy things for you. Even in the future, you'll be able to learn about those stuffs, right? So up to now, just keep in mind that these physical quantities having a same set of units, right? That doesn't mean pressure the similar word for pressure is Young modulus. So these are separate types of physical quantities, even though these having same types of units. So that's the thing, right? Okay. Now you are asking you have to obtain the incorrect answer, right? So keep in mind that in the first one, you asked to obtain the unit of Young's modulus, right? So keep in mind that in order to obtain the Young's modulus, just remember the pressure. Now you are asking about the units of Young modulus, right? So this is something difficult for you. So that's why keep in mind that instead of obtaining the units of Young modulus, just find out the units of pressure. Then you can able to obtain the answer, right? So okay, right. So let's first of all just remember the what is the equation for pressure? Pressure mean force over area, isn't it? Pressure mean force over area, right? So let's find out the SI units of pressure. SI unit of pressure mean let's substitute the force as kg in is minus 2 over units of area mean in square. So that's mean this is the SI unit of pressure. This is the SI unit of pressure. This is the SI unit of pressure, right? Okay. On the other hand, in generally, we use Newton to measure the force, right? So if I substitute the unit of Newton as the unit of force, if I substitute Newton as the unit of force, then the area is can be substituted as the square meters. So likewise, n into the power 2 also can be considered as a unit of pressure, right? So if it is, both these units can be accepted as the unit for Young modulus, right? So that's the importance of remembering those similarities. Okay. Okay. Then we can able to consider both these units as a unit of measuring Young's modulus. So the first answer should be correct, isn't it? Okay. Then pressure. So pressure is measured newtons per square meter. So the second one is also correct. Third one, energy. Right. So now you are asking about the energy units of SI unit of energy. Right. So as I mentioned earlier, try to figure out the unit for energy. So I'm using potential energy. So what is the equation for potential energy? mgh. Right. So likewise, if I substitute the values, m is measured by kg, gravitational acceleration is measured by ms minus 2, and m is measured by m. So this is the unit for energy. So the given answer is incorrect. So the answer should be the for the first fifth one is third one, right? Okay, and there's another thing that you need to remember here. You can able to obtain the unit of for density for sure, you know. And here there's another term that is this also is a new thing for you, guys. Right, surface tension, right? Surface tension is a physical quantity, right? So you will learn about in future. Even though, keep in mind that I will tell you the unit of surface tension. Right, surface tension is obtained by force over length, right? So it's better to keep in mind this equation. Surface tension mean force over length. So that's mean if I obtain this SI unit for surface tension, that is kg is my kg is into the power of minus 2, right? So this is the SI unit of surface tension. So if I obtain the unit of surface tension in general units, I can able to substitute the Newton as the unit of force and meters as the unit of length. So this unit also can be accepted as the unit of surface tension, right? So then the fifth one is also is correct, right? So the answer should be obviously the third one. And I want to mention another thing that is that there's another word tension. right? So here it is surface tension, and here this is tension, right? Tension means there's a similar mental disorder called as tension. But I'm talking not about the mental disorders, but about the physical quantity, right? So normally tension means, it is better to keep in mind those stuff. Tension means force exerted on string. Force exerted on string. So that means tension is a kind of force, right? Tension is a kind of force. So that means the unit of the tension can be also considered as kg ms minus 2, right? But keep in mind that surface tension and the tension are two different types of physical quantities, right? So they don't having a same units or the same idea, right? So these are different physical quantities. So it's better to keep in mind that, right? Okay, let's move on to the sixth question. Pressure cannot be measured by which of the following units, right? So another physical quantity which having a different types of unit is pressure, right? So as we discussed earlier, pressure can be measured by using kg m into the power minus 1 s into the power minus 2. So this is the SI unit of pressure, and we can also can be used newtons per square meters as the unit of pressure. And there's another one that is Pascal. Normally, we use Pascal because Pascal is a special name or special unit which is used to measure the pressure, right? Right. So likewise, these are the same. These are units which is used to measure the pressure. Likewise, guys, there's another one that is atmospheric. Atmospheric at all. We can able to call it as atmospheres, right? It is represent that the unit of the atmospheres is represent as ATM, right? So this is also is a use which is used to measure the pressure, right? So normally we call the normal pressure, normal atmospheric pressure as 1 atm, right? So that means 1 atmosphere. So this is also is used to measure the pressure, right? On the other hand, this unit also used to measure the pressure. Mercury centimeters or mercury millimeters. These are units which is used to measure pressure, right? So keep in mind that, so these are new things for you, but you have to adhere about those stuffs, right? So obviously the answer should be the fifth one. Okay. Let's move on to the seventh question. A basic physical quantity and its basic SI unit is not correctly indicated in which of the following quantity unit pairs, right? So the answer should be the third one, isn't it? It is very simple thing because mass is measured in kilograms, not by using the grams. Okay. In the eighth question, which of the following are usually measured by G? G means joule, right? So work done by force. So I mentioned you that work and energy having a equality. So that's mean the unit which is used to measure the work can be accepted as a unit of energy. On the other hand, the unit which is used to measure the energy can be also used to measure the work, right? That's so likewise the Joule can be used to measure the work done by a force. So the first one is correct. B. Gravitational potential energy. Guys, even though it is there's a prefixes that is called gravitational potential energy, it is the same as a energy. So likewise, the joule is obviously can be used to measure the gravitational potential energy. Right. Then moment of force. So I have given the relevant equation for moment of force. Right. So momentum force, the unit of the moment of force is Newton meter. So this is similar as the unit of work, no? So joule is also can be used to measure the moment of force, right? Uh, so then therefore the answer should be the fifth one, right? Okay. Now this is the end of the spot exam number 2, right? So I think you have learned some additional things for your knowledge, right? So that's likewise we have to do a lot of questions. So then you can able to understand, guys, by doing questions we can able to learn some theoretical things, addition to the theoretical points that we learned as a theory, right? So doing a question is a one kind of method which is used to considered as a learning material, right? Especially for the subject like physics, right? Okay. So then let's conclude this session. So have a great day. Do your best, right?